Necessity of the modernization of the fireworks manufacturing sector in India. Article written by V.R. Ajith Kumar and published in Kalakaumudi May 3 to 10, 2026 issue Part 2. In the first part, we discussed the issues related to traditional firecracker manufacturing units. In this part, we examine the modernization taking place in developed countries. It is high time that India also moved toward the modernization currently transforming the global fireworks manufacturing industry. Scientists and research institutions should come forward to seriously engage with this sector and undertake meaningful research. While the fireworks industry in India still depends largely on human labor, Liuyang, the Sivakasi of China and fireworks manufacturing centers in Europe have shifted extensively toward automation and green chemistry. Liuyang, which produces nearly 70% of the world's fireworks, is leading this transformation. Thousands of small and unsafe factories there have been consolidated into regulated industrial parks. This has enabled centralized safety monitoring and allowed the high costs of automation to be shared collectively. The use of unlicensed chemicals and illegal manufacturing practices is controlled through digital tracking systems. Every stage is digitally monitored, from the moment raw materials leave the warehouse until the finished product reaches the market. This clearly shows that the traditional Indian practice of manufacturing fireworks in temporary sheds and open fields has long been abandoned in Europe and China. Fireworks are now manufactured in specially designated industrial zones equipped with advanced infrastructure. Buildings are constructed using explosion-resistant technology. Reinforced concrete walls, modern safety systems, and blowout roofs are standard features. If an explosion occurs, the damage is contained within a limited area, while the roof collapses outward without endangering nearby workers or buildings. Pyrotechnics is the scientific field related to fireworks and firecrackers. The chemical reactions involved in fireworks combine heat, light, smoke, and sound in both an artistic and scientific manner. Fireworks are visual and auditory wonders that deeply fascinate human beings. Shells, sparklers, skyrockets, safety matches, signal flares, and explosive display effects all come under the field of pyrotechnics. In reality, pyrotechnics integrates inorganic chemistry, material science, and combustion science. This is a field where chemistry and art merge together. It involves both safe and hazardous chemicals. Through continuous research, safer chemicals and advanced machinery are developed while dangerous substances are gradually eliminated. It is unfortunate that premier Indian institutions such as Council of Scientific and Industrial Research and Indian Institutes of Technology have not given adequate attention to pyrotechnics research. The selection of chemicals is extremely important in the fireworks industry. International manufacturers are moving away from volatile substances such as potassium chlorate. Instead, they use oxidizers that are less sensitive to friction and impact and are chemically more stable. Although India officially restricted the manufacture of potassium chlorate-based fireworks in 1992, the chemical continues to be widely used. Ordinary firecracker mixtures generally contain 75% potassium nitrate, 15% charcoal, and 10% sulfur. However, potassium chlorate is often illegally added to increase sound and brightness. Unfortunately, enforcement agencies frequently fail to detect or prevent this misuse because of systemic collusion and weak monitoring mechanisms. Recent innovations in China are driving the development of greener fireworks systems. Plant fibers and specialized catalysts are now being used in manufacturing. These innovations reduce combustion residue by up to 80% and minimize the risk of accidental ignition caused by environmental factors such as extreme heat. The shift toward high-tech powders also reduces the risk of damaged shells breaking accidentally on the floor and triggering explosions. The most dangerous stage in fireworks manufacturing is the mixing of chemicals. Friction, heat, or even a tiny spark can trigger a chain reaction. In India, this process is still largely carried out manually by workers. In contrast, modern factories use mechanical stirrers and automated feeders. Machines accurately weigh and mix chemicals in precise quantities. Even if a fire breaks out, the machinery may be damaged, but human lives can largely be protected. Modern manufacturing facilities also use stepper motors to fill shells with chemicals accurately and safely. Artificial intelligence-based monitoring systems detect even slight increases in temperature or mechanical friction and automatically shut down production lines before an explosion can occur. Since static electricity is often responsible for sparks, modern machinery uses special engineering plastics for all parts that come into contact with explosive substances. Digital firing systems are now widely used during fireworks testing and public displays instead of manual ignition. These systems allow technicians to operate fireworks safely from hundreds of meters away using encrypted radio frequencies or fiber optic cables. All of this requires a high level of technical expertise. At present, there are no dedicated pyrotechnics courses available anywhere in India. Most workers in Sivakasi acquire basic knowledge directly from firecracker units through practical experience and trial-and-error methods. In Kerala, the traditional Gurukul-style apprenticeship system is still followed for training pyrotechnicians. Even internationally, there are very few full-time undergraduate or engineering programs dedicated exclusively to pyrotechnics. However, Cranfield University offers a short-term course in pyrotechnics. The course includes pyrotechnic device design, construction techniques, firing demonstrations, and the chemistry of explosives and ammunition. It is also recognized within the broader field of MSc-level explosives engineering. Other available programs include the Postgraduate Certificate in Pyrotechnic Design and the Global Certificate in Pyrotechnics. These courses cover fireworks design, safety and risk management, display planning and execution, the science of fireworks, and the chemistry of colors and combustion. Many of these programs are conducted online and lead to professional certification. In China, fireworks manufacturing and pyrotechnics research remain under strict government supervision. Workers in Liuyang receive continuous technical training. Modern manufacturing techniques, safety systems, and export standards form important parts of this training. Research, testing, product classification, and safety certification are ongoing processes there. In the final episode, we will discuss what India can do to modernize fireworks manufacturing, particularly in Sivakasi, as well as the possibilities for research and academic development in the field of pyrotechnics. Please stay tuned for the concluding part. Kindly like, share, and subscribe to the channel for more videos. Thank you for watching the video. Thank you.